A dust collection system begins with the material and process, not the blower catalog. Identify the dust, consult its safety information, and determine whether it is combustible, toxic, respirable, abrasive, hot, or mixed. This film is an engineering architecture guide for woodworking and industrial buyers, not a certified design or a customer installation. Stop before selection when the dust identity is unknown, a combustible dust assessment is missing, the capture hood is undefined, or the discharge and collector location have not been reviewed. Metal, food, coal, polymer, silica, lead, and mixed dust cannot be treated as ordinary sawdust. Qualified specialists and the applicable authority must resolve those hazards. Trace the complete path: source, capture hood, branch duct, main duct, cyclone, downstream filter, blower, and safe discharge. Capture must begin where dust is generated. A powerful blower cannot recover material that escaped the hood, and visible cleanliness does not prove exposure or fire safety. Inside a cyclone, dusty air enters tangentially and forms a rotating flow. Inertia moves larger particles toward the wall, gravity carries them into the collection bin, while the inner vortex carries air and finer particles toward the outlet. This is a conceptual cutaway, not a claim for a specific cyclone geometry. A cyclone is usually a separator or precleaner, not a final fine particle control. Smaller particles can pass downstream, and higher efficiency geometry generally adds pressure loss. Match downstream filtration and emissions control to the actual particle size distribution, health hazard, process, and local requirements. The blower operates where its fan curve intersects total system resistance. Hood entry, duct friction, branches, bends, dampers, the cyclone, filter loading, leaks, and discharge restrictions all shift that point. Free air CFM is not capture flow at the machine, and no universal duct diameter or velocity fits every dust. Place the blower according to the engineered system arrangement and exact equipment limits. On the dirty side it may handle abrasive particles, on the clean side it depends on upstream separation and filtration. Rotation, motor suitability, guarding, temperature, material compatibility, and access all require verification before operation. Combustible dust turns collector location, ignition control, grounding and bonding, electrical classification, explosion relief or suppression, and deflagration isolation into system-level decisions. These are not optional accessories or generic do-it-yourself steps. Never stage a dust cloud, spark, flame, or compressed air blowdown for a demonstration. Commission with measurements, not appearance. Verify airflow direction, hood capture, static pressure at defined points, branch balance, blower current, vibration, abnormal sound, leaks, filtered differential pressure, and safe discharge. Record a clean system baseline so later loading and deterioration can be recognized. Monitor the cyclone for plugging, erosion, air leakage, bin overfill, and unstable inlet conditions. Monitor filters for pressure rise, damage, bypass, and an approved replacement limit. A clear-looking outlet or spinning dust stream is not a compliance test. Exposure and emissions require the appropriate measurement method. Before clearing a blockage, opening a bin, changing a filter, or reaching near a rotor, shut down and apply the site's hazardous energy procedure. Electrical, pneumatic, gravity, vacuum, and rotating energy may remain. Housekeeping must match the dust hazard. Dry sweeping and compressed air cleaning can resuspend dangerous material. Release the system only when the dust and process are defined, capture is verified, the operating point is documented, downstream filtration and discharge are suitable, combustible dust decisions are resolved, and maintenance limits are recorded. A good dust collector is a measured system, not a blower number, a dramatic vortex, or a one-size-fits-all promise.